What's up friends, it's Devin here with Make Anything, and in today's video I'm gonna design and 3D print some cool accessories for my new 360 camera and for this YoFace electric skateboard by Bustin Boards. And since Bustin gave me this board for the video, in some ways I'm kind of a sponsored skateboarder now. But you know, it's no big deal. Oh yeah, my first skate part. Seriously though, this board is so fun to ride. Basically, this all started with me looking for ways to cut down on driving since most of my common commutes are shorter distances and you know, gas prices. So electric skateboards came to mind as an alternative that I figured I would enjoy. And as you saw, I've definitely been enjoying this for a lot more than just commuting. I've been skateboarding super casually for quite a long time. And as I researched all the different electric skateboards out there, this YoFace V3 Hybrid by Bustin Boards really stood out to me as being the closest thing to your standard street cruiser boards that I'm used to. It's got a kicktail so you can pop over obstacles, the trucks are great for carving and maneuvering through tight spaces, you can still kick push like a regular skateboard, and technically you could even grind these trucks. It really feels like a street deck that's been supercharged to the next level. I mean, this board is no toy. You've got this controller and you just turn the wheel to effortlessly hit 27 miles per hour on flat ground. So, like the name implies, this board will in fact bust in your face if you don't take precautions. Hence, my first order of business was to deck out my helmet. Of course. Here it is, my trusty helmet I've had for well over a decade, and it still works fine, but as I was scraping off some old stickers, I discovered that there's just this thin layer of gray over black plastic. So how cool would it be to strategically scrape off that gray and make a custom design? I decided to try a Damascus steel texture. I've always liked the chaotic waves and ripples of that material, so I sketched out a few approaches to getting that look, until I got this one I'm pretty happy with. So let's give it a shot. Dremel sent me a few of their cordless battery-powered rotary tools and some carving bits, and I think they'll be perfect for this job. This really pointy bit will help me get the thinnest details, and for the rest, I'll use the Dremel 8260 with this rounded carving bit. That should help me carve wider areas without removing too much material. I've got my safety glasses as well as my respirator, and some gloves so I don't lose my grip. And I started off very cautiously, just getting a feel for the tool and what it takes to get through that thin gray layer. With the Dremel at half speed, it only takes a light touch, and I got the hang of it pretty quickly. It also helps that this is a pretty organic design, so I don't have to worry too much about absolute precision. Like a lot of art, this is certainly an act of patience, but that rounded carving bit does make relatively quick work of this. In comparison, here's the pointy bit doing its thing, making some really thin lines and sharp points. As you can see, the basic idea is to create these rough concentric lines and to have them vary in thickness and spacing in different areas. After an hour of this, the weight of the Dremel can get tiring on the wrist, but I remembered I have this flex shaft attachment. This thing extends the tool to this much smaller and lighter handle. Now I can hang the motor up and out of the way, and it's a huge improvement on the handling and comfort. So I went ahead and did all the larger details with that rounded bit, and then I swapped out the bits to fill in the fine details with that pointy bit again. Surprisingly, the Dremel batteries outlasted me, and I was having fun, so I ended up covering the entire helmet. Maybe I overdid it, and some areas definitely look better than others, but overall I think it's a pretty cool and unique design. Alright, now I can protect this beautiful brain with style. Sorry, that's my brain talking. I also got these K2 race gloves with plastic plates to protect my hands and wrists, and yeah, they already came in handy. And after that fall, I also got some lightweight knee pads, so I feel relatively protected now. But I know myself. I'm a destroyer. I break things, and this board ain't cheap, so I need to protect it as well. Oh, and my camera. I definitely need to protect my new camera. This is the Insta360 ONE X2 camera, and the reason it looks so funky is that it has two opposing lenses that each capture a 180-degree view, and combined they make a full 360-degree video. That can be used for VR videos, or to get a shot that can be reframed in post to get all kinds of unique shots like the ones in my skate video. The Insta360 software also stitches together the footage in a way that makes this selfie stick disappear. It's like magic, and it would be really hard to get these shots any other way, let alone filming by myself. So that's very cool stuff. Unfortunately, for the X2 to see in every direction, the lenses are left very exposed. And I did buy lens protectors, which already served their purpose. I've bumped into the ground a few times while filming, but even when I was just handling the camera while transferring files and charging the battery, I found myself accidentally touching the lens all the time. And it comes with this neoprene cover, but that slides on really tightly and makes contact with the lenses, so that just made me uncomfortable, and I knew I had to design some new accessories for this camera. And then deal with the skateboard. Now, the design of this ONE X2 has some pretty subtle surfaces. So while it's probably possible to get all the necessary measurements the old-fashioned way, with calipers, I really wanted a great reference model to make sure my accessories fit really well without a million iterations. So I figured this would be a great opportunity for 3D scanning. In theory, if we get a great scan, we can import a near perfect representation of this object into our CAD software and build directly around it, which is a huge help. So I decided to try out this Pop 3D scanner sent to me a while back by RevoPoint. This tiny USB-powered infrared scanner is marketed towards hobbyists, and it raised over $2 million on Kickstarter in 2021. So let's see if it can accurately capture this camera. The Pop 3D scanner is pretty straightforward. I was able to plug it in and scan this test piece really quickly. You can reorient the part to get all the angles needed for full coverage, and in this case, the software did a great job of combining all those points into this coherent mesh. We have lost some fine details in the lips and eyes, but it's still pretty cool, and I was easily able to print a tiny replica. Since the scanner uses safe infrared light, I was even able to scan my own face pretty well without any assistance. The X2 camera, however, is a bit tricky because it's dark and it has some reflective surfaces, which are both weak points for most 3D scanners. The RevoPoint software does have a specific setting for dark objects, but I still had trouble getting it to track correctly, and even when it did, you can see the smooth surfaces came out a bit lumpy. So the limitations of this scanner are showing here. So the scanner is pretty cool, and I think it could work really well in a school or a hobby setting for scanning clay sculptures and the like, but for today's project, I need a really accurate 3D scan to make the best fitting accessories for my camera and skateboard, so I'm gonna switch over to my trusty 𝐒𝐓𝐋 SP scanner right here, which I've already used for several projects in the past, and it's got more of a calibration process. The turntable is software operated, and it projects visible light onto the subject, so it's a little bit less straightforward than the Pop 3D scanner, but it has an advertised accuracy 3 times greater, so hopefully it does the trick. Here's the 𝐒𝐓𝐋 SP setup, and as you can see, it's pretty similar. As with the Pop 3D scanner, I can scan the part from several orientations to get a complete scan, although I did have to use mounting putty to hold the camera steady since the turntable is abruptly starting and stopping constantly. So the scanning does take longer, and some of that putty will end up in my finished scan, but the quality of the scan is really fantastic. I'll take that STL file into Mesh Mixer where I can get rid of that putty by just deleting those faces and then filling the gaps using the Inspector tool. Next, I'll bring that file into 3D Builder, and the first thing I'll do is rotate the model to line it up with the global XYZ coordinates. It seems my 3D scans are always saved in weird orientations, which is kind of annoying. Anyways, the next thing I'll do is add the clear lenses that weren't captured by the scanner since they're totally reflective. Thankfully, it turns out they form a perfect sphere, so I just matched the size, aligned it in place, and merged that sphere with the rest of the model. It's finally ready for Fusion 360. So I'll insert the mesh, and then use the Reduce tool to lower the triangle count so it's easier to work with. And now we can switch into the solid modeling workspace and build around it as usual. I did still model this cleaner reference based on the scan, but this process takes out a lot of the guesswork and should definitely result in more accurate designs. The first thing I designed was a simple stand for setting my camera on my desk while transferring files and charging the battery. Nice, simple, and stable. Then, most importantly, we have a nice hard shell case that makes it very difficult to scuff up those sensitive lenses. And thanks to all that work I put into making a reference model, I was able to design this really precisely so it's got an excellent friction fit with the edges while avoiding all the sensitive components around it. I feel way more comfortable carrying this around compared to the included slip cover or even the other silicone covers available for sale. Only this one is certified Devon proof. And that's a high standard. I printed these on my Sovol SV01 Pro using polyterra filament, and these nice matte colors just make it look so good. Not all my ideas worked out though. I did try making this Weeble Wobble style monopod using some weights attached to the bottom of the selfie stick, and the idea was that you would be able to just toss this thing somewhere and it would stay upright. But after testing my first iterations, I realized pretty quickly that this would take a pretty hefty, heavy base to counter the weight of the camera at the end of this 4-foot selfie stick. Something about physics. Anyways, I did come up with a different accessory that's still pretty fun. It's a big spike, and using a standard 1/4x20 bolt, it mounts to the selfie stick so that you can quickly stab it into the grass, dirt, sand, and the like, and quickly set up different shots. It actually works really well, and it's still compact and lightweight. Whoa. Overall, I think this camera is super cool. Maybe it's got a niche use case, but it can get some really incredible shots. And maybe VR is finally approaching a point where it's worth shooting 360 video. I'm not sure yet. Yes, it is a bit delicate, especially for skating around with, but cool nonetheless. And hopefully my accessories will help it survive a little bit longer. I do have a few more ideas for this camera, and of course I'd love to hear any fun ideas you might have. After all, now that I have my reference model, it'll be much easier to design more things for it in the future. But for now, I think it's time we circle back to this skateboard. As with the camera, I wanted to design some add-ons to protect this thing from my destructive energy. And also, like the camera, it doesn't have a very straightforward shape. This deck specifically has a lot of complex dips and curves that do make it more comfortable to ride, but a little trickier to design for. So once again, I figured it's worth 3D scanning this thing. Of course, this skateboard is a lot larger than the camera. It's not gonna fit on those turntables, so our process is gonna be a little bit different. This time around, I'll simply set up my board in an open space and make sure it's stable. Then I'll stick on a bunch of these little markers. Since our object is too large to scan all at once, these markers should help the 𝐒𝐓𝐿 software align and piece together a bunch of captures to create a complete model of our skateboard. I'll speed through this part because it takes about 15 seconds for a single scan, and capturing the entire board takes dozens of scans. So this was not a quick process, and despite all the markers, the software often had trouble identifying them, so I managed to scan one side of the board, but I wasn't able to get a complete scan on my first 2 attempts. So for my third go, I added way more markers, and since we're dealing with another dark object, I decided to cake the board with climbing chalk in hopes of getting a cleaner scan. There are dedicated sprays that do this in a much tidier fashion, but I was working with what I had. Finally, I used clumps of masking tape and putty to make my own markers around the wheels and the thin edges of the board, since that's where I had trouble with alignment on my last attempts. I figured these blobs would provide the software with more identifying information to reference for alignment. This time I started scanning from the bottom of the tail, since the main thing I want to design is a tail saver. And little by little, the models started coming together. The 𝐒𝐈 SP is mounted on a small tripod, so I was able to get scans from up above, and I also took the scanner off the tripod to get some low-angle scans as well. I gave it a valiant effort with 133 combined scans, but despite that, I just couldn't successfully capture every area. But I decided the tail looks good enough, so I went ahead and let the software patch things up to create a watertight mesh. And the result looks pretty usable. So I saved that as an STL to bring into MeshMixer, where I can align the model to the XYZ planes, cut away the floor, and edit away all those markers I stuck on the board. I'll also cut away everything except for the tail and reduce the mesh to as few triangles as possible without losing the critical dimensions. I generally aim for a mesh with under 10,000 triangles to keep Fusion 360 happy, and I took this model from 1.5 million triangles down to 8,000. Not bad at all. So I hopped into Fusion 360 with that mesh and designed my part around it. Clearly, there's just too much to this project to show everything in this video, but I will make this Fusion 360 file available for Patreon supporters to download and play around with. Anyways, here's my tail saver in Fusion, and here it is in real life. So I should probably explain what this thing actually does. Basically, like most skateboards, this deck is mostly made of wood. Only mostly because the YoFace here has a special thermoglass core, which to my understanding is a kind of fiberglass epoxy insert that gives it more strength and stiffness. Nevertheless, anytime this tail hits the ground, material is going to be scraped off. So if you're popping ollies and doing terrible failed manuals, it won't take long to shave that tail down to a fragile razor edge. It's a common reason for having to replace regular skate decks, and electric boards cost a lot more, so we really want to preserve this board for as long as possible. So my solution was to cause a little more destruction first and run these 4 bolts through the tail. For one thing, it's a very robust way to attach the printed part without any adhesives, so it can be swapped out really easily. But the main reason for these bolts is that they're holding onto these sacrificial nuts. These nuts line the bottom edge of the board, and they take the brunt of the damage when the tail hits the ground. And let me tell you, these nuts can take a beating.
Even when one edge gets worn down, you can just rotate it or flip it over. And since these are pretty standard 5/16 18 nuts, they can be replaced for pennies.
Thanks to all the work I put into scanning this tail, the printed part was a perfect fit. Though I did still go through a couple of iterations. First, I printed this thin shell just to test the fit in real life before putting more work in. And the print failed right near the end because the filament snapped below the runout sensor. But it was still enough to test the fit, and as I mentioned, it was perfect. First try. That's pretty rare. From there, I designed this part that's slightly thicker, and I added the mounting points for my 1/4-20 bolts. The nuts sit in these pockets so they can't spin around and unscrew themselves from underneath the board. This version was pretty close, but I could still make some improvements. So for my latest version, I slightly changed the orientation of the nuts so that the pockets print more cleanly without support material. And I also added some surface texture to the edge and top here to add some structural rigidity. Now, these ridges on the side also help us get a cleaner print from this overhang because it's essentially printing a bunch of little overhangs instead of one larger one. And that trick is surprisingly effective here. Though to be fair, the older one was printed without a cooling fan because at first I was trying to print these using a recycled styrene filament from closed loop plastics, which is really cool, but it requires a high printing temperature and heated enclosure. So I used my typical janky enclosure setup with the SV01 Pro, and it got so warm that the fan duct actually melted. So maybe I pushed my printer a bit too far with that attempt. Anyways, that's when I switched to this Rep Wrapper modified PLA filament, which has been holding up really well so far. And speaking of holding, I also modeled a little lip onto the bottom here so that you could carry the board more easily from the tail. Considering this thing is 14 pounds, that's been pretty handy. Also, I wasn't totally sure if the bolts sticking up from the top would be annoying while riding, but this actually acts as a bit of a foot stop that keeps my back foot from sliding off the back. Generally, it also gives me some indication of my foot position without having to look down at it. Sure, if you're trying to do more advanced tricks on the board, it might interfere, but I really like having that tactile feedback. Anyways, let's take a look at how I actually installed this thing. Here you can see how the board was already starting to get ground down after a few hours of riding, so let's bring this to the workshop and pop on our print. It's critical that the tail saver is totally snug against the board, since any air gaps will create weak points. So I used this large bar clamp to hold it firmly in place while we drill our holes. I printed these drill guides that fit snugly into place to ensure that we're drilling straight through the center of our mounting point, starting with this 1/8" drill bit to create our pilot hole. I followed that up with a 1/4" drill, way too close to my fingers, and then a 5/16" bit to create the final hole. Then I installed a 5/16 18 nut and bolt to secure it into place. I know, those drill guides are a bit sketchy, I did rush to have them print really quickly, and I have redesigned them since then to be a little less scary. But it did work, so I continued down the line, drilling and installing the remaining 3 bolts. Since the print keeps the nuts in position, we can simply tighten the bolts from above until they're pretty snug. Optionally, some washers here would help distribute those forces a bit more, but the plastic didn't crack or anything, so I just kept it like this. At the time, I didn't have the correct 1-inch length bolts on hand, so I just decided to cut these longer ones down using my cordless Dremel 8250 with their premium metal cutting wheel. I just made sure to be patient, and I jumped between the different bolts while cutting to keep them from getting too hot and potentially melting the plastic. There we go. As planned, when the tail comes down to the ground, only those steel nuts make contact, sparing the board itself. By now, I've ridden some 300 miles on this board with lots of crappy ollies and some pretty aggressive scrapes. And this tail saver has absolutely been doing its job. So far, I haven't even had to replace the nuts yet, just rotating and flipping them every now and then. And the plastic edge has also taken a few hits, but it's holding up well. For my riding style and what I'm trying to do on this board, I would call this design an absolute success. It does exactly what I intended. That said, I am always trying to inject a little extra excitement into my designs, so I made this Phoenix tail. This was my attempt at recreating a classic skateboarding accessory called the Tail Devil, which similarly sticks under the tail of your skateboard and shoots off sparks when dragging across the ground. I actually had one on my board in my last skateboarding video when I designed a magic witch's broom to push me around. I'm a sucker for sparks, so I always really liked the Tail Devil, and I thought it would be fun to add something similar to my tail saver design. Now, I don't know exactly what Tail Devil uses for theirs, but I figured these ferro rods, usually used by survivalists to start fires, could do the trick. So I modified my tail saver design ever so slightly to hold onto one of these rods. It's generally the same, but with this added compartment where you drop the rod in, followed by another small print, and when installed, it's all held into place. The idea was to have the rod at a position where it hits the ground at the same time as the steel nuts to keep the rod from grinding down too quickly while still shooting off some cool sparks. And it sparks. Now, thanks to the Phoenix tail, all my failed manuals still look kinda cool. Unfortunately, the rod popped out long before it actually got used up. So I made this tape barrier and filled the pocket with PVA glue. I was trying to avoid adhesives, but at least this is still biodegradable. Once that was dry, I reinstalled it, and it did last an extra couple of days, but still broke free much too soon. That's as far as I've gotten with this Phoenix tail for now. I don't want to resort to using epoxy, and even shedding some PLA and PVA dust isn't really worth the sparks. So I'm still trying to figure out the best way to install this ferro rod. Leave a comment if you have any ideas. Now, you might have noticed that I've also got a nose guard up front here, and while I didn't get a clean 3D scan of the nose, I did discover that the very front of the board has virtually the same shape as the tail. It just rounds off a little differently to the sides here, so I was able to take the same tail saver design, and I just narrowed it down to the middle 2 bolts. That way I'm still protecting the very front of the board, plus I gotta leave these corners open for all the kick flips I'll start busting out. Any day now. And since I'm not really planning on popping off the nose, I was able to give it a much larger handle underneath, and that makes this board even easier to carry. This time I decided to print the part using that experimental recycled tire TPU I got sent last year from Sharudo, which was a Michelin incubator program. It still doesn't seem to be commercially available, which is a real shame because it worked great. I installed the nose guard much like the tail saver, and I was a little worried about the flexible material prying off when I hang onto it, but this TPU seems really strong. It's certainly more impact resistant than PLA, so I'll probably print my next tail saver in this material if I have to replace it. Alright, me and my board are now better protected, which means I can feel more comfortable on my daily commutes, and maybe a little more daring with my tricks. Great, that's cool and all, but what if I told you I figured out a way to ride 100 times faster? See this thing? You just pop it on and boom, instant speed. Yup, all it takes is this little attachable spoiler, and then you speed up the clip in your video editor. Fascinating. The spoiler is printed in a few pieces, including the sides, which I printed in 2 passes for some essential flame graphics, and the rest is just glued together, including these magnets. I realized that since the bolts are magnetic, it's a quick and satisfying way to snap something into place. It might be a good option for securing some headlights on the front, or other things that are a bit more practical than this thing. But what can I say? It was the YouTuber in me. So, slap me with a like and leave a comment if you've got any other fun ideas for the board. Finally, I want to thank Bustin Boards for sending me their YoFace V3 Hybrid board. It really ended up being the perfect board for me, making my commutes real fast and fun. It's small enough to maneuver well, but hefty enough to feel relatively safe on. I'm always cautious to avoid rocks and other things that could jam my wheels, but I have still hit a few on the YoFace, and these 90mm wheels just kick them out of the way, instead of kicking me off the board. I appreciate that. Also, it's really nice that this board is a hybrid, because it can still be kick-pushed manually, and it's heavy, so you wouldn't want to do that for too long, but the fact that it can roll on its own does make it feel more natural, and if the controller were to die out of nowhere, it would just roll out instead of grinding to a sudden halt, which has apparently happened on some other belt and gear-driven electric skateboards, and caused some nasty accidents. No thank you. One upgrade that I would love to see would be an even bigger battery, or even a swappable battery, because, well, I'd love to ride this thing all day non-stop. Apparently with the lowest speed setting, there's a range of about 14 to 16 miles, but that caps out at around 10 miles per hour, and I'm just not gonna do that when this thing is so fun to ride at 25. So the way I've been riding it, I found that I can get about 7 miles before I get the low battery warning on my controller, and then at around 8 miles, the board will slowly start to reduce its top speed until it's completely out at 9 or 10 miles. But the main trip I make is to my climbing gym, which is 8 miles away, so it's perfect. I have noticed the low battery warning coming on a little bit earlier now that I've skated 300 miles, so hopefully the capacity doesn't decrease too quickly, but so far, it's a freaking awesome board. If you want updates, feel free to join the Make Anything Discord channel and ask away. I'll put a link in the description for that, as well as all these STL files, in case anyone else is bold enough to drill into their fancy skateboard. And I'll also link to the YoFace V3, the Insta360 camera, the 3D scanners, all that crazy stuff. But right now, I just want to say thank you so much for joining me on another adventure. Have fun out there, and as always, stay inspired. Let's go!